in this section we're looking at variable acceleration. So there's lots of times where acceleration isn't uniform. As soon as we have non-uniform acceleration, then we can't use our equations of motion that we've been using, our 5 equations, because they're for our variable acceleration. So what we need to do is actually use some calculus. Okay, so the idea here is for, if we were to draw acceleration time graphs or our position time graphs or our acceleration time graphs, okay, then they're not necessarily linear. So that's what we're talking about. Okay, so we're going to use a bit of calculus. But a bit of a summary of how we do this, okay, is if we're given our displacement, we're going to get our velocity, then we're going to differentiate. If we're going to go our velocity to acceleration, we're going to differentiate again. Okay, and if we've got our acceleration, we want to get to our velocity, we anti-differentiate or integrate. If we want to go from our velocity to our displacement, we anti-differentiate. Okay, so we'll have a look at a couple of worked examples here. So we've got the motion of an object along a straight line is modelled by the equation v equals minus t outside of t take 5. Okay, where v is in meters per second, okay, and t is in seconds. Okay, what is the acceleration at t equals 3? Okay, at t equals 3. So the idea here is we've got velocity and we want to get acceleration, so we've got to differentiate. Okay, so acceleration A is equal to our dv dt. Oops, dv dt, sorry. So if v equals this, okay, well, easier way is to expand out our brackets and say, well, v is minus t squared plus 5t. Okay, so that dv dt equals minus 2t plus 5. Okay, using our knowledge of derivatives. Okay, so simply if we want to find our acceleration at t equals 3, well, we know now our acceleration equals minus 2t plus 5. So acceleration at 3 seconds is minus 2 times 3 plus 5 is minus 6 plus 5. Okay, which is minus 1 meters per second squared. So at the time t equals 3 seconds, we're actually slowing down. Okay, so the idea here of this value, okay, is if we have our graph, which of this looks like that, okay, and that point's 5, okay, and this is our point 3, okay, that our tangent to that point would have a gradient of -1, okay, which are found by doing our derivatives. Okay. We flip over for our next worked example. We have a dog starts from rest to go on a walk. Its acceleration can be modelled by, so we have acceleration equals 3t minus t squared. Okay, where our units are meters and seconds. What is the distance the dog has travelled in the first 5 seconds of its walk? So for this, we need to look back and go, well, hang on, we're up at acceleration and we're going to get down to displacement. So we're going to have to anti-differentiate to find velocity and then anti-differentiate again to find our displacement. Okay, so if we integrate our A with respect to t, okay, then we get our velocity. Okay, so we need to 3t minus t squared dt. Okay, well, that's going to equal 3 on 2t squared take 1 on 3t cubed plus c. Now we need to get rid of our constant of integration. Okay, well, when we start at t, okay, our velocity is 0, okay, because we're just starting off, and our t is 0. Okay, so we'd say 0 equals, well, 0 for these, so c would have to equal 0. So our velocity equals 3 on 2 t squared minus 1 on 3 t cubed. Okay, so that's our velocity equation. Now, the problem is though, we've got to also find, okay, our integral of this, because if we were to graph our velocity time graph, okay, so if we were to graph this function, Okay, it goes like this. Okay, and we want to find the area up to 5, okay, which this crosses between 4 and 5. Okay, so the area we're going to try to find is this area here. Okay, so we've got a little bit of a problem, okay, with finding this. Okay, because the reason is there's negative area there. If we just integrate this from 0 to 5, we're not going to get the right answer because this area is going to be positive and this area is going to be negative, so we're going to take it away and it's not going to be right. Okay, so we're going to have to do this in parts. Okay, but first of all we need to know when we cross our x-axis there, so we need to factorise our equation. So if we go v equals t squared outside of 3 on 2, take 1 on 3 t. Okay, then we can use our null factor law to set this equal to 0. Okay, when this one's equal to 0, well, that's going to be our intercept at the origin here. What we have, 3 on 2 take 1 on 3 t equals 0. Okay, so negative 1 on 3 t equals minus 3 on 2. Okay, so t equals 9 on 2. Okay, so it is at that point there, is at 9 on 2 or at 4.5. Okay, so now we can integrate this equation, okay, with our terminals. So I'll do it over here. So we're going to integrate our 3 on 2 t squared minus 1 on 3 t cubed between 0 and 4.5. Okay, and then we're going to add on, okay, or if you like, take away, because this area is going to be negative. So if we take it away, we're going to end up getting positive from 4.5 to 5 of our 3 on 2 t squared minus 1 on 3 t cubed. Okay, oh, I need my dt's in here as well. Okay, so when we do that, we find when we integrate this, we get t cubed on 2 minus t to the 4 on 12, and that's going to go 0 to our 4.5, minus our, again, t cubed on 2 take t on 4 on 12 from 4.5 to 5. Okay, when we sub in our values here, okay, then we end up, I'll sub them in, I'll just bring it over here. So if we say we've then got 4.5 cubed, take 4.5 to the 4, that one's on 2, this one's on 12, okay, minus our 0 cubed on 2, take 0 to the 4 on 12. Okay, we need some brackets around all this. Okay, and then we're going to do the same thing over here. Okay, summing in our 4.5 and our 5, so we've got 4.5 cubed on 2, take 4.5 to the 4 on 12. Okay, sorry, that one should be our 5, not our 4.5. So that's our 5, this one's our 4.5, 4.5 cubed on 2, take 4.5 to the 4 on 12. Okay, and when we do all that and work out this would be 0, we can work that out, we can work it out that, and then work out that. When we do all that, then we end up getting that we're at 11.39 minus negative 0.97, so it'd be 11.39 plus 0.97, okay, which equals 12.36 metres. Okay, now we're probably going to be a bit rusty on some of this stuff if we haven't got to it in methods or specialist. I mean, we're running through the specialist textbook in order. Okay, so we haven't hit it yet. Okay, so don't get too bogged down in some of these steps here. You can always have a look at what you're doing in maths methods as well.